Infection prevention control has lots of concerns about machines and equipment that have buttons that are not flat and continuous. They offer many opportunities for bacteria to hide in the protein and create kind of a gunge around the button, and that certainly is a risk from the infection prevention control perspective.
This is a point-of-care testing thermometer. We're going to do a quick demonstration of how virtual buttons might be applied to a device like this. The problem with mechanical buttons like this is that they allow grime and dirt to hide in the crevices like this one. This becomes a breeding ground for nosocomial infections, and superbugs can hide and grow in these crevices. It is extremely hard to sterilize such mechanical buttons. With virtual buttons, we can place buttons on any existing smooth surface, even curved surfaces, and solve some of the problems with hospital diseases. If we were to apply virtual buttons to a point-of-care testing device like this thermometer, we might put the power button here and the mode change button here, or anywhere else where it's most ergonomic for the device. We would just print the button on the existing perfectly smooth surface so there is no problem with infection control. In this case, if we want to turn the device on, we provide a very slight tap in this location. And if you want to see the last temperature, press the mode button. And in Celsius, press it again, back to Fahrenheit, and then we might turn the device off. This medical pump has membrane buttons. All the buttons are covered by one large, flat membrane. The problem with membrane buttons is that they have a crevice that goes around the edge of the entire membrane. This crevice is very hard to sterilize. Dirt and grime get caught in it, and it is a perfect breeding ground for nosocomial infections. Virtual buttons, on the other hand, will not have any cracks or crevices like this, making it very easy to sterilize an entirely smooth surface. The main advantage of virtual buttons on medical devices is that virtual buttons don't introduce any new cracks, crevices, or seams associated with the user interface. This means that virtual buttons can be applied to any existing smooth, even curved surface, so that you can very effectively sterilize a medical device, and it increases hospital workforce efficiency as well, because they can very quickly do the effective sterilization. Other devices like, or other user interfaces like even membrane buttons, mechanical buttons, or even touchscreens introduce cracks, seams, crevices that are very difficult to sterilize with whether it's sterilization wipes or other things. Nosocomial infections are becoming more and more of a concern in the medical environment, and not only do we have to wash our hands, realizing we have to wash our hands more often, we also have to worry about the sterilization of the devices that those hands touch. Thank you for taking the time to allow us to explain virtual button technology and some of the advantages that virtual buttons have. We believe that virtual buttons have the capacity to revolutionize user interface technology in a number of different fields. We at the VBT team are continuing to apply virtual buttons to new applications and continuing core technical development, improving the technology.